Hello and welcome to this video. In this video, we're going to look at how are we going to do three-dimensional Pythagoras theorem. Okay, so if you remember Pythagoras theorem, it was whenever we had any right angle triangle, we could always say that we could call this side A or B and this side C. The position of the C matters, but we could switch A and B. And we said that the relationship was that A squared plus B squared must always be equal to C squared in a right angled triangle. So how could we put this three-dimensionally? Well, usually the question might ask you, they might give you a cuboid, so we have some 3D shape. So let's say we have this cuboid here, and they might ask you then, given that we know that this length down here is 10 centimeters, this length here is 5 centimeters, and the height of this is also 5 centimeters. Actually, let's make it more like 4 centimeters, or let's go with 8 centimeters. Given that we know these lengths, they might ask us to work out what is the length from this corner up to this corner. So if you can imagine this in 3 dimensions, it's from the very front bottom corner of the box to the very back top corner of the box. And they might ask us, what is this length, which I'm going to call x? And we can work this out. The way we're going to work it out is we're going to say that, well, we can split this into 2 triangles. Okay, the first triangle I'm going to look at is this base triangle here. So the first thing I need to do is I need to work out this diagonal that's going across here. And if I were to take a top-down view, so a top view of this 3-dimensional shape, looking at the base of it, the thing that I'm doing is the base of this is 5 centimeters by 10 centimeters, and I'm saying, well, what is this horizontal length here? And essentially, if I get rid of these 2 lines, that is a right angle triangle, where this is A and this is B, and I just want to work out C. Okay, so I can do this. I can just say that 5 squared plus 10 squared is equal to C squared, and that's just going to be equal to C squared. Let's leave it like this for now. We'll see why in a second. But then what we're going to do is we're going to say, well, I know that now that I know this, and I know this height is 8 centimeters, then if I take a side view, I can say that this is actually a right angle triangle going along here. This here is a right angle triangle. And so if I draw that out, I'll have an 8 by, this side is 8 centimeters. This side is the base of it, which goes all the way across, which is 5 squared plus 10 squared. And this side here is x. And that's what I'm trying to work out. This should technically be square rooted when it's a length. But what I'm going to do to work out x is I'm going to do 5 squared plus 10 squared all squared, the square root of all of that all squared, plus 8 squared is equal to x squared. So I'm going to end up with an expression that says x squared is equal to 5 squared plus 10 squared plus 8 squared. Okay, so by splitting this into 2 separate triangles, we've actually technically derived what the 3-dimensional Pythagoras formula would be, which is if I have some diagonal that goes through this, where this length here I'm going to call A, this length here is B, and this length here I'm going to call C, this diagonal D is related by the fact that this diagonal is x squared, so D squared is equal to A squared plus B squared plus C squared, where A, B, and C are just the dimensions of this box. So if we wanted to work out D, you can go through this idea of having the top view, working out this diagonal that goes across here, then doing this kind of like cross-sectional view, working out this triangle through here, and then working out what x is, the distance across. And you could do this in 2 steps like that if you wanted to. That would be completely fine, but this down here is kind of like a shorthand. So now we have something for 2 dimensions. And now if we have 3 dimensions, we can use this formula, and that's going to tell us the distance from corner to corner. So this isn't just applied to rectangles, it can be applied to any shape. This formula, to stay safe with it, I would say only applies when this is A, B, and C here. So this is going to be just for a rectangle. But this method of working it out will work for any shape, and you'll always be able to do that. So this is 3D Pythagoras. Jump over to the questions video to see more practice of how we're going to do this, and thank you for watching. Hello and welcome to this video. In this video we're going to be going through some 3-dimensional Pythagoras practice questions. So let's have a look at this first question. We've been given a cuboid that's represented by all of these letters. They've told us that AB is 5 centimeters, BC is 7 centimeters, and AE is 3 centimeters, and they've asked us to work out this diagonal length of A through to G. And they want us to give our answer correct to 3 significant figures. So if you remember back to the revision video, we said that if things are in a cuboid shape like this, they're quite nice because we can say that this 5, this 7, and the 3 that would be here, but it's just drawn over here, the 3 here are the dimensions that make up this triangle. So we said we could make it easy by calling this D, calling this A, B, and C, and then say that A squared plus B squared plus C squared is equal to D squared, only when we have a situation like this. But that makes this one nice and straightforward. That's just going to be 5 squared plus 7 squared plus 3 squared is equal to D squared. Now 5 squared is 25 plus 49 plus 9 is equal to D squared. When we add these all together, this becomes 58. That's then going to become 83. So D squared is 83. So therefore D is going to be the square root of 83, which you can kind of assume is going to be around 9-ish. So we'll just put that into a calculator. So the square root of 83 is equal to 9.11, correct to 3 significant figures. And remember, it's a distance, so it's 9.11 centimeters. And so now let's have a go at the second question. So we've been given a cuboid again with the dimensions of 3 by 4 by 12. We said before this is going to be A, B, C, and the diagonal we're just going to call D. And we said in the case where it's a cuboid, we can say that A squared plus B squared plus C squared is equal to D squared. And then we just substitute in all the numbers. So A squared becomes 3 squared plus 4 squared plus 12 squared is equal to D squared. 3 squared is 9, 4 squared is 16, 12 squared is 144. So 16 plus 144 brings us up to 160. So D squared, this is still equal to D squared. So if I add all these together, I get 169. So D squared is equal to 169. And the square root, so D is the square root of 169, which is 13 centimeters. Okay, so hopefully these are straightforward. Let's do one last one that's going to be a bit more challenging. So this diagram shows a pyramid. The apex of the pyramid, meaning this point at the top here, is V. Each of the sloping edges is of length 6 centimeters. The base of the pyramid is a regular hexagon with sides each of length 2 centimeters. This is a top-down view where this is V, the apex at the top, going through O at the bottom. Calculate the height of V above the base of the pyramid, giving your answer to 3 significant figures. Okay, so if we were to take a side view, what we would want is we would need to look for, we would first want, well, our final goal is to find this height, which I'm going to call H for now. Okay, but in order to do that, we know we need to make some sort of right angle triangle out of this since we have a hypotenuse. And so if we were to make a line that went straight from the middle to a point, we would then be able to work out what is this overall length. And there's kind of a sneaky trick in here to be able to see where we're going to go with this. And that's the idea that you need to be able to spot that these are equilateral triangles. They don't say this in the question, so it's quite difficult to be able to tell. The way you can kind of figure it out is think, well, I know this side here, so AB is a length of a side of length 2 centimeters. So this is 2 centimeters, and I have kind of a parallelogram here, which means that this side must also be 2 centimeters. Now that is all you need to know, because it tells you that if this from here to C is 2 centimeters, then here to D is 2 centimeters, here to E, all of these lines are all 2 centimeters, which means that these are all equilateral triangles. Okay, so if it wasn't clear before, hopefully that proves it. And what that means is this distance here from O to D that I've drawn along the base is actually 2 centimeters. And so I don't actually need to do anything three-dimensional in this case, because I can spot this little geometric trick. And so to solve for H now, I've just got this triangle where I know this side is 6 centimeters long, I know this side is 2 centimeters long, and I'm trying to work out H. Now to do that, this is A, B, and C. So C squared minus B squared is equal to A squared, and so 6 squared minus 2 squared is equal to H squared. Therefore H squared is going to be 36 minus 4, which is 32, and H is going to be the square root of 32. Now it wants this to 3 significant figures, so we just have to grab a calculator and put in the square root of 32, and we get an answer to 3 significant figures that H is therefore equal to 5.66 centimeters. And this is our answer. So hopefully now all of this three-dimensional Pythagoras is a little bit easier. Hopefully it all makes sense, and thank you for watching.